Another uplifting talk about failure. So I'm going to talk about the story that we went through for the past couple of months. We received an email a couple of months ago from our VP of engineering that they want us to actually stop any more investment in DevOps initiative for a couple of our teams. While receiving that email was not the most fun thing that it can happen, it was not very surprising. Some of our teams were not actually dealing very well with this initiative. They were struggling. There were a lot of pain points. The project was going a lot more expensive and a lot more time-consuming than what we estimated even in our worst-case scenarios. So I want to tell that story, and we did a bunch of root cause analysis after the fact to figure out what were our lessons. It's OK to fail as long as you have your lessons. I've put those lessons together, and I want to share them with you. So maybe it would be helpful to some of you, hopefully. For understanding the context of this story, it's important to know what are the people, what are the players, what do I mean by we failed, who is we. So I'm a developer. I work at a company called ThoughtWorks. We do a lot of consulting for enterprises. So what it really means, it means we have a group of developers. We go on site with the client, and we ship some products together. And in this journey, we introduce some best practices. For example, and these best practices cannot only be DevOps. It can be about testing, about lean product engineering. It can be about many different things. Today, I'm going to talk about DevOps part of this initiative. The client that I'm speaking about is a healthcare company. They are your typical gigantic enterprise of healthcare, about 100K employees all over the world. They are mostly dominating the west part of the US. They're a $15 billion operating revenue company. Obviously, we are not working with this whole company all at once. We're working with one division at a time. And the division that we chose to start with was the innovation group. The whole reason that the innovation group exists in this big company was to become the change agent in that big company. They are the team that have to adopt new technologies and new best practices, and they enable the rest of the company to be able to use those practices. There were about 100 people. This includes the engineers, the operations people, also the managers, and all the product engineer people. So how did the teams in this client look like? We had a couple of teams. Each of these teams are product teams. They're focused on a single product, mostly web applications. They are pizza-sized teams, which is very good, small teams. And there's one team that's a little bit different, and that's the operations team. These teams didn't really have a lot of dependencies on each other. The only dependency was the operations team, and very typical classical operations. You have a request as a developer, you create a ticket on their board, they will pick it up, they will run with it at some point. As a developer, I know a little bit about what's going on in my servers, but not that much. I'm not responsible for it. I just create tickets. It's not my domain of expertise. So you have these teams going on, and the infrastructure that they put together was a little bit hacked together when we started. So when they started these products, they wanted to go live very fast, and someone went to AWS. This was all in cloud, which was the good part. No hardware, real hardware dependency. But some people went through the AWS console and just click, and created the infrastructure. It was not built with infrastructure as code in mind, or it was not built with automation in mind, which is OK. It's OK to start lean and small, and later on, when this product actually has customers, start automating things. As what I was saying, this is a healthcare company, and they're kind of forcing their patients and their doctors to use this application. So as a result, this product actually had a lot of need. There were people who were caring about these applications. The infrastructure was in a situation that when we entered in, not too bad, but imagine we are seeing these scenarios of we have a test environment, and now we want a staging environment for the same application. And I remember seeing one developer sitting and has two monitors side by side. And one side is the test environment configuration, and the other one is the new staging environment. And just go one by one. What's the network port here? And just replicating the same thing over and over. And it took months to create a new infrastructure for one of our servers that was a little bit more complicated. I'm not saying anything crazy here. These are the typical things that we all see, we all know about, just setting up the context about what it looked like when we entered. The knowledge about these servers are a tribal knowledge. One person knows about how AWS part, one person knows about the server part, typical, classical, not automated infrastructure. So we thought, this is easy. We can actually make a big impact here. It's not that hard. Let's put everything in source code, obviously. There are two things that we want to source control. One thing is about the AWS configurations. What are your server ports? What are your security groups? What are your servers? What are you using a medium? Are you using an X large? Things like that. And there's another part of things that we want to automate, which is the actual server provisioning, the applications that are installed on the server. The first part, we use CloudFormation. If you haven't used it, it's not rocket science. It's just a JSON file that describes a group of things together. For example, you can have one JSON file that says, I have a load balancer and a server and a database. And it just groups them together. And you can put that JSON file in your source control. And you can revision it as you're changing your environment. You can see the changes. And for the second part, which was what are the things that you're configuring on the box, we chose to use Puppet. This environment was very Windows heavy. And at the time of this choice, Puppet was the most mature tool between Chef and Ansible and things like that. So this would solve a bunch of our automation problem, but the mentality of the DevOps was still there. So what we thought to do, we look at these teams, and on one side, we have all these people who know a lot about applications and don't know anything about servers. On the other side, we have all the people who know all the knowledge about servers. So let's move people around. Let's have a thin layer of infrastructure only on there, which is responsible for provide the tooling for the other teams, and spread the knowledge. So imagine I am a person that was in the infrastructure team first. And now your whole world is just product team A. From now on, you don't worry about the other servers. You are only supposed to support product A infrastructure and operations needs. Also, enable these people. Pair program with them. Do lunch and learns. Do whatever it takes for this team to become self-sufficient and minimize the amount of requests that are going from this product A team to the infrastructure team. So this was our original plan, and we started. And we went through this process for a couple of months. And as I've told you, it didn't go as smooth as this plan looked like. There was a lot of learnings. Some of the teams, this worked out very well for them. Some of them didn't. The lessons that we learned from them, I've categorized them in three main categories. The people part, the organization part, and the tools part. Let's start with the people. The people is the easiest part. That's why we do retrospectives, right? That's what we do that to blame people. Let's start with blaming people. No, it's not blame people. So learning curve. We started by saying Puppet and AWS and all these things. And it's very easy to fall into this trap of, we know these tools. I know these tools. I've been using them for a couple of years. We go to conferences about these tools. These tools are in our comfort zone. Any team should pick them up. It's easy. You go and you pair program, and they pick them up. In reality, it was not that easy. Some of the teams were able to pick them up very fast. 2 weeks, it was surprising. But some of the teams, even after 4 months of pair programming and handholding, they were still not self-sufficient. So when we looked at this, we realized that it's not about people that they were smarter or whatever, but the teams that had the least adaptation were the teams that, for example, imagine I'm a developer on that team, and I am a front-end UI guy, and every week 3 new frameworks of JavaScript coming out, and that is my world. That's what I want to learn about. That's what I go to conferences for. And now this new consultants coming in, and they're pairing with me on a bunch of new technologies that it was not on my career path. It was not something I'm really motivated personally to learn about. So those teams struggled the most with, and our expectation was not that. Our expectation was after a couple of weeks, each of these teams are enabled and self-sufficient. So I want to, in retrospect, I wished we had spent more time in empathy, as John was saying yesterday, about the tools that we feel comfortable. Not everyone feels like that. Other than the learning curve part, we had, for enabling the learning to happen, we always do this thing that what's the smallest thing that we can do to make a developer comfortable with the server infrastructure. So I'm a developer, I have this code, my code runs on my machine, and I want, someone is telling me you have to care about how your code runs in production. We do this thing called, let's just put a VM as a baby step. Let's put a VM on your box. Doesn't matter what you use. VirtualBox, Parallels, doesn't matter. And we put a production environment, similar to production environment on your VM. Obviously, it's not going to be similar to production. It's just a tiny VM on your machine, but that's OK. And we changed the developer workflow to whenever you're finished with the story and you want to say, I'm done, let's do one more test. Let's do a deployment to this VM first on your local machine that is simulating your production environment and see how your deployment goes for this piece of code. And that has shown over and over that actually helps a lot, because this is a small baby step on my machine, and now I can start caring about how my code behaves in production-like environment. While this worked for a lot of teams, for some of the teams it didn't work. It turns out too many people on the team are using Microsoft Surfaces. They're tiny little tablets with 8 gigabytes of RAM, and someone is telling me to put a VM. No, I'm not going to put a VM on this. It's only 8 gigabytes of RAM. I'm not running a VM that has a Windows 2012 server on it. So, and no, I'm not going to change to a beefy machine just to have your new consulting thing going on here. I'm not going to do that. The teams that weren't able to have a VM on their machine and weren't able to get the feedback loop fast as a developer had the biggest pain. Because what happens if you don't have a VM on your machine and you still want to have the life cycle of caring about how your code behaves in production? Now suddenly you have to play with these things in AWS. If you want to play with your IIS configuration as a developer or your Apache configurations, the easiest thing is, OK, get a box for you, get a sandbox box for you in AWS, remote desktop to that, and do your experiments there, which these people were all on Windows. And you have to remote desktop. It's all a sluggish window. It's not a very fast feedback cycle for a developer, and it's not something fun to do, really. And guess what? If I'm not having fun doing this, I'm not going to do it. If there's an easier way to do it, I would just check in and push in and hope for the best that it will go fine in the pipeline. The second part of the learnings were about the organization. So I showed you this chart that looked very cute. You just put these people over here, and it's fine. We weren't able to change the HR roles. So although people were moving teams and physically sitting with a different team, their desk was there, they were still reporting to their old boss in the infrastructure team. So when it comes to who am I actually making happy, who is doing my performance review, this is a very enterprise-like environment. The hierarchies really matter. It matters if I make my boss happy or not. And my boss is over there, so that is my real team. I'm just temporary here. Some of the teams, I remember overhearing this conversation that we are sitting together, a developer wants to make a change to production. And they are pair programming with the designated ops person inside their team. And the ops person says, let's open a ticket. It's like, no, we did this whole thing to remove the ticket part. All of this initiative was about removing, throwing things over the wall. Why are we documenting things again? The whole point was this team to be self-sufficient. So some of these teams were successful. And it turns out that this is completely by accident, I guess. The person who we designated as the ops person was more motivated in enabling other people. You know, this kind of people that you have in your organization that are good at sharing knowledge with other people. Or some of them were really motivated about their product. So you imagine you're the operation people and you go to the product A, and you actually care about product A. You want to make product A successful. And in those situations, guess what? They gel well together, and the DevOps magic happens. And when it doesn't gel, and I don't feel belonging in my team, although I'm physically sitting with them, it's not a part of my team. If you watch how people go to lunch together, you can see the patterns. You can really understand who is in which team. The other thing that we saw was, so imagine these teams are all running independent. You have come as a leadership and you said, your vision for this team, the vision is you build it, you run it. You're responsible for development, you're responsible for production. It creates this tension after a while. This team A wants to use Splunk for their log aggregation, and team B wants to use Elk Stack for their log aggregation. Is that okay? Maybe, sometimes it's okay. One team wants to use a Bamboo for their CI. Another team wants to use Jenkins. Is that okay? Or how much are we forcing federations and how much are we forcing standards? I wish in retrospect we had spent more time in setting up a clear expectation about what kind of company are we going to be. And although a lot of these decisions really come bottom up from developers, some of them, like this one, is an exception. I strongly believe something like this has to come from a vision of the leadership. What kind of company do we want to be? Where do you draw the line? Is it okay to have 10 different CIs for each of the teams? Is it okay to have 10 different languages? Are we forcing a language? Or how far do we want to go? Are we forcing frameworks now? Are we forcing the tools that we use for unit tests across the floor? I wish in retrospect we had more conversations with the leadership team about what kind of environment they want to be. And the last the last set of learning were about the tools. So we all have these tools. We all use CIs, and CIs is where all these things come together. When I was talking about put everything in source code and have things in CloudFormation and Puppet, at the end of the day, CI is the place that pulls this thing out of GitHub, does some magic, does the deployment, or does the provisioning. CIs always have this tool, all of them have this tool, that you're creating a build step, and you are adding a new build step, and it asks you, what kind of step do you want to add? And you say, for example, I want to add the source code. I want to have a source code here. And you can have a bash source code, you can have a PowerShell source code, doesn't matter. But one of the options is, I want to enter the source code here. So it gives you this text box, and you start putting your text script there, which is fine. All of them do that, and I have used this feature many times. It was the first time I saw how problematic this feature can be when it comes to the ownership. So when you're thinking about the developer mindset, as a developer, the script that goes here can never be a first-class citizen in my toolchain. I didn't write this script. This is a script that operation people write. It is not in my toolset. It is not in my GitHub repo. It's not close to my source controls. When I'm checking out my project, this script doesn't get checked out. I can't do a review check. I can't do a git blame and see who wrote this line. I can't do code reviews on these things. As a result, these things tend to rot. This thing stay in the CI, and when you were transitioning through DevOps, and you want each team to own these parts, these scripts was the hardest script to change the ownership. As a developer, I don't want to touch this. I don't know what they do. There is zero test coverage for this. We're working in a PowerShell environment, and that team was very rigorous about using unit tests even for their scripts. They use Pester for PowerShell to even test their scripts. Zero test coverage for this. I'm not going to own this unless I want to rewrite this. And that creates all these discussions about should we rewrite, how long does it take, and things like this. So one of the examples of what's an alternative to this is when you put all these scripts inside your source code. Imagine Sam Newman talks about this simple API. For example, you want to push something to production. And the API is, I have a deploy script, name of my app, the version, and the name of the environment. It says the API should be as simple as this. Where is the logic for this script? The logic for this script should live somewhere in some source control and that a developer can care about. I should be able to load that logic up, that script, that deploy script, whatever that does, in my favorite text editor and play with that. All your CI should do in these kind of steps should just run this. And guess what? When you're thinking about your script just running this simple line, then the amount of maintenance that you have to do on the little text box just goes away. It was interesting to see how this change of the tool option can actually affect the ownership of the code. I also talked about AWS CloudFormation. So when you're using CloudFormation, you see this kind of view that you're seeing your stacks. So imagine this is a production stack, a developer stack, a development stack, and a test stack. As I said, our client was all in AWS, a single account. And there are some problems with this approach. One of the things that we found is if you are in product team A, you only want to see product A stuff. You want to restrict access of person who is working in product A to touch or change product B infrastructure. There is no easy way right now in AWS to control these roles in a maintainable way. I want to enable people, I want to enable the product A people to have all access to the dev environment. It is your environment, go tear it down, go change it, do whatever you want with it. And I want to give you that access as a maintainer of permissions in AWS. But I don't want you to be able to change product B. And the tooling that AWS right now provides doesn't support this easily, especially when you're thinking about stacks that are Phoenix stacks. So every time you're doing the new deployment, this whole stack goes away and a new stack gets replaced by this. There is no easy way to maintain those rules. There is this blog post on segment.io that they talk about how they rebuild their infrastructure. And they have a very interesting solution for this, as they are having multiple AWS accounts for dev environment and test environment and staging, and with the same single operation overhead. So all the payment is in the ops role, and it applies over multiple accounts. And they talk about how it plays out very well. We had to actually do this very late in the game. In the retrospect, it was a perfect fit for that. If you're having multiple teams and you want to give full access to them, especially for the dev and test environment, this is a very good approach to take. So wrapping up the learnings. Don't underestimate the learning curve for the tools that you feel comfortable, that you have been using all the time. Set clear vision and expectation about the federation versus the standards. How much standards do you want to force? How much federation do you want to go? Set expectation, about, especially with your leadership, about what kind of company they want to be in that sense. And stop programming against your CI. Those scripts are not going to be maintainable. And with that, I would like to open it for questions. Hello, magic people in the back?
Sorry about that. So we got some questions. Just raise your hand and it's fine, gentlemen. I think you two are supposed to swap. But.
Not a lot of questions.
We got one over on the right
there.
side.
Why do you call that the failure? Did they end up just canceling the whole thing?
So a couple of these teams stopped using our tools. It was so painful for them that even right now, after months, it is still a touchy subject. When we are talking about infrastructure as code, it has a very bad memory of bad taste in their mouth that, no, I don't, this took a lot longer than what it was supposed to take. Also, it went a lot more expensive. As imagine you're the leadership of this account, you're the VP of engineering who brought these consultants in, and the consultants are expensive, and you want, in a short amount of time, to see the max benefit. And that didn't really happen. The return on investment didn't happen. We did a bunch of automation in the dev layer and the test environment, and they're still in the test environment. Those automations never went to production, which is an absolute waste, because they have actually added more trouble. Because now the way that we deploy to dev environments is different from the way that we deploy to production. So we had to actually take it out. It was a lot of waste. That's what I'm calling it a failure.
Any more questions? We got one in front here.
Great talk. I've definitely experienced that fun struggle of people keep wanting to write more code in the CI, script box. How would you convince people that, pulling it out of there and just having like the one thing that in that box that just invokes the shell script or whatever that you have checked into source control, like how do you actually convince people to do it that way? Like by example, or how do you make that happen?
So a couple of ways that we tried. Some of them worked, some of them didn't work, obviously. One of them was to set the expectation about what the API should be. We call this thing strong local builds, which means as a developer, you should be able to do the same thing that your CI does on your development environment machine. You should own that part. And we showed the examples, like imagine a lunch and learn. We were having a bunch of problems when tests were running fine on your developer machine, but you check it out because that script is so different from how you test on your local machine that it's failing over there, but it is running on my machine and things like that. And we showed the difference that if you're using the exact same toolset over and over, these problems will go away. So I guess pair programming, awareness about the problem, what's the actual pain that you're trying to resolve, things like that.
Great. So just raise your hands if you got questions, and we'll get the mic runners out to you. I think that's it?
Thank you very much.
All right. Thank you.